Let's review the Monday quiz problem and incoming grace test and final examination. So, whenever you wanted to see the upgraded learning material, you must go to snoomath.com and then click discrete math 1 or 2 uh, for the upgraded learning material. So usually, the the learning material is saved in your computers as a cached file. And then when you open the file again, then the cached, when the saved learning material will comes out. So you cannot see the upgraded one. So if you see the upgraded learning materials, go to snoomath.com and see snus.com. But this is not a real address. I mean, this is this is a kind of uh, short, abbreviated uh, address. The real address is when you hit this one, so you must use HTTP rather than HTTPS. So this is HTTP through mass.com. Then this address will be replaced by the real address. This is the real address. This is the real. And this is a user-friendly shortened address. So the real address is now, this is HTTPS. So SME is a security, okay? So this address is more secure than HTTP address. Anyway, please use HTTP snoomath.com, then automatically this will be replaced by the more secure real address. Anyway, now you are in the our learning website. Then click discrete math 2, and then now we are approaching to Google server, and then take out updated learning material. So it takes time to uh, try to read the upgraded one, and then call the material, and then try to show you the new one. So it takes time. So depending on the internet speed, okay. So there comes a learning materials. So as usual, let's import the Python library by clicking this one. And then let's see. So it's running still. It takes time. And all the materials uh, is rich to my computer. So think about it. So that means okay. Let's try again. So it takes okay. This kind of thing happens that depending on the computer internet speed. So I click this one. Okay, now this one is running. Depending on the computer internet speed, this is running. And when it is executed, there comes a response. So inside the behind of this icon, the Python code is hidden inside of learning material. So that Python code is now executed, and so it takes time. Okay. So this one happened in my computer. Hmm. Um, Okay, this one is executing. So that means now it is executed. So now we are ready to use the learning Python library. Okay. So by clicking this one, let's go to our homework three. Homework three. Then just uh, move the cursor to the lower place depending on the computer speed. So also it takes time. I think this learning material is too big, so I will plan to reduce the size of this learning material too, uh, because we are not studying this materials, not this one. Okay, so we just use around this place. So I plan to delete everything in the future so that then the speed will be upgraded. So this is homework one. This is the prime factorization. So once again, this will be uh, our final examination problem. So you should memorize the Python code, the factorization code. This is a one of the most important code in discrete mathematics to study. Also, this is the homework one, and homework two is so now we are studying the sum of integers, and that is also the important one of the important topics in discrete mathematics. So in this case, we wanted to visualize the summation in terms of this kind of cube blocks. So this is Pascal triangles. This. Okay. In fact, this one is a kind of text code. This text code will be transformed to our mathematical symbols, but I think that due to the computer speed, this text code is not uh, executed to produce a suitable math symbol. Okay. Okay, so this one is so this is the sum of summation formula for the integer squares. This is the geometric method to prove the formula, this formula. So there are many ways to prove this important formula. The using geometric three-dimensional cubes or this kind of two-dimensional figures, but we will prove this one using a modern uh, method that is generating function. Generating function is related to differentiation and power series and Taylor series. And also it's important in learning probability and statistics. So in discrete mathematics, the modern discrete mathematics, generating function is, I think, the very important topics. So generating function and graph theory are the two most important topics in discrete mathematics. So now we will approach this one using generating function. But before that, we need to prove some necessary uh, fact. That is Pascal identity and binomial theorem. So, this is the okay. This is the Pascal identity, and this one will be used in to prove the binomial theorem. So you try to understand this one. Okay. Binomial theorem. Let's go to binomial theorem. Okay. The homework 3 is to prove the binomial theorem. So this will be a kind of Gray's test problem. Okay. So review test problem. Okay. So uh, in review Gray's test problem, we will this problem will be given in review Gray's test problem. But the final examination is will be this one. Sigma k zero n n and then and choose k. Okay, and then this one is it's k then y n minus k. So, but it doesn't matter. Okay, this kind of thing. So this is a more generalized version. Generalized version. So this is a more simple form. Simple form. Okay. But for the review grace test, this one will be given, but at the final examination, this one will be uh, given in the final examination. So try to see the generalized version uh, to prepare the grace test and final examination. So this is the simple one, Pascal identity, and this one is a more general one. But if you replace, so I mean, general one is this one, but if you replace x is one, and then this one will be 1 plus y to the n. So this is more general. So now, so I will explain a more general one to prepare the coming grace test problem and the final examination. And there is a very good YouTube video to explain this theorem. So I uh, recommend you to watch this YouTube. But suddenly there is a very the error comes out. So everything is perfect, but I think the Google don't want to see YouTube from the inside of this collab. I don't know why. So this is a uh, this is a the, the code. This code is not there is not an error, but I think the Google don't want to provide YouTube inside of this collab IPRMB. So anyway, so this is the YouTube, but there is an error. Yeah, so instead, the Google uh, produce this kind of thing. Okay, that means see the YouTube video from uh, what YouTube app. Okay, so just click this one. Okay, click this one. Then the the YouTube video will comes out. So so that means the Google don't want 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 you to see the YouTube inside of this uh, learning material, but go to YouTube youtube.com to see this video. So as I explained in the above, so in English, there comes watch video on YouTube, this kind of thing. Then just click this link to see uh, the video. So let me show you. So just click this one. Let's click this one to see what happened. So when I click this one, okay, then there comes a new website and web browsers now calling the so, see, this is kind of a mm, skip this one. This one. So this is a very nice one. So let me explain this one using his uh, YouTube. So this is a general room, okay? This is general diagram. So instead, many people use this one. So n choose k, but uh, you may use n minus k by k. Now j is increased by k. Then you have this one, okay? But this one is exactly equal to n choose k xk by n minus k. It doesn't matter. Okay? It doesn't matter. They he used so now he tried to prove Pascal identity first. So in fact, this one is not a good proof because we need to prove this one. Factorials, k factorials, and minus k factorial. So this is also kind of a theorem. Theorem to prove. Okay. Well, now he used this one as a fact. He used this one as a fact. So anyway, this one is also this one is not a good proof, but it's acceptable in computer science for the computer science student. But for mathematics student, this one cannot be allowed. Okay, because this one is important. This one is okay. And choose zero, nothing but this is now we agree that this one is one and choose n is now we say that's one. There are three steps in the mathematical induction. First one, choose the case for where n is one. You can try this, okay? But this one is this is okay. Okay. So a check whether this one is K1. But interest no need for it, but it just show you the theorem when n is two. Okay. But there is no need for the mathematical proof. Okay. Then now we assume the case this one, but for the case n. So let's assume this. Okay. And then we want to prove the case n plus one. So this we assume the case n. Let's try to prove the case when n plus one. Yeah. Because plus y n plus one, that is x times x plus y plus y x plus y n. Okay. So we will use an already accepted formula to so this one is agreed. Okay. What's Pascal identity? Some of those two, and choose k minus one plus and choose k minus two, okay, and choose k. Okay. So some of those two, what is this? One, two, there, some is and choose three. Sorry, I made a mistake. Okay, in the Pascal identity, so n minus n minus case. That is n case. So that was a mistake. So he just so let's return to our learning material. Okay. So by clicking this one, you can see the general version of binomial theorem. You can see the one. So this one is exactly equal to this one. But so in the Grace test, you may use this one. You may try to prove this one, but it's acceptable. So this is the final examination problem. This one is k is to n and choose k. So so now let me try this. This is n minus k y k. Okay. So also this one is as I said, this is k0 and can choose k, x, k, I, and minus k. They are the same. But the order is different, but the final result is exactly the same. So you may use this one or this one, but in this YouTube video, he used this one, this formula. Okay? So at the grace test, both of them is okay. Okay. So, but in the final examination, this one will be you must prove this one. This is more general version, but in our the incoming grace test, you may prove this one instead of this one. But try to study the more general one to prepare the final examination. Okay, then let's go to homework 4. Homework 4 is this is homework 4. So this is now we are entering uh, Newton's generalized binomial theorem. So this is Newton's generalized binomial theorem. Until then, so we study 1 plus x like this one. But this one is this n number n is or must be integer. Must be integer. This is the classical binomial theorem. But now Newton generalize the classical binomial theorem and say this n may be any real numbers, any number. I mean then that can be one over two. So Newton now can study this one. This is 1 plus x, 1 over, okay? And also what it is. This one is now 1 minus x, minus x, minus 1. So now Newton's general binomial theorem can approach this one and this one also, because now this n can be a negative numbers or the rational number, any number. But the classical binomial theorem, this n must be integer, positive integer. So this is a more generalized one. So the homework four is to prove this using this generalized binomial theorem to prove this identity. Okay, so let's go to but now you can use differentiation and integration. Okay, now this is homework 4 is write mathematical proof for the following equation. So this is the Monday quiz problem, Monday quiz of this. Okay, 1 minus x to n. So in fact, this one is 1 minus x minus n, okay, minus n, like this one. So then from this one, that is k is 0 to infinity. Now this is the infinity series, okay? So now this one is minus n. So this is minus n k x. So in fact, this one is 1 plus minus x, the minus n, okay? So in fact, our one is plus sign is assumed, but this one is now minus. Then you must use this one. So that is it's important. Minus x, the case power. Okay, so this one is equal to this one. So but minus x to the case power is equal to minus 1 case power and x case power. So you can replace this one as minus 1k, and then you can erase this minus sign here. Okay. So this is okay. Then this is okay. So now you must compute this one. compute this one, and then the the goal of this the goal of this proof is now you should show this one. This one this one is equal to n plus k minus 1 k. Okay. Then this one is exactly equal to this one. Okay, from the generalized binomial theorem, that is they are equal. So let's prove this one. This one is equal to this. This is the key for the Monday quiz problem. So you may see this video, this is my video, and you can see the proof. But there may be two different proof. So for the Monday quiz problem, try to write down both of them. Okay. So the first one is using the Newton's generalized binomial theorem. So this one is just what I explained. Just okay. This one and this one. So let's prove this one is equal to this that one. Okay. That is the key. This is the first method. And then why this one is they are the same, but just try to the computation. Okay, so let's show. So now look at this one. So we must prove that this one is equal to n plus k minus 1 k. Okay, so let's go step by step. Then what is minus n choose k? And that is the starting one is minus n. The next one is minus n minus 1. Okay. The next one is minus n minus 2. So this is decreasing order. And there are what k many numbers in the numerator. The denominator that is a k factor. Okay. So that's so look at this. Minus n minus 1 minus n minus 2. So the last one is minus n minus k plus 1. So how many quantity in numerator there are k many, okay, k many. So you get this multiple plus 1. So denominator is k plus 1. Okay. Then okay. Then let's replace this one by this one is minus 1 times n. Okay. So what is it? This one is also minus 1 times n plus 1. So minus n minus 1 is minus times n plus 1. Okay. So just separate this one into two parts. So this one is now this is minus 1, and the last one is n plus 2. This. So now this one is now the increasing order. The last one is so the minus 1 is just uh, take out minus 1 sign, then the remaining one is n plus k minus 1. Now there comes minus k minus k. So as you see this one, n plus 1, n plus 2, plus k minus 1, and now there comes how many minus 1s are there? The k many, okay? So this one is now you can get this kind of okay. So and then this is minus xk is minus 1 to the case and x to the k. So finally you can get what minus n choose k and minus x to the k. So this one is, and then you can combine those two like this, and there is this one is minus 1k and xk. Okay. And then minus 1 to the k's power, minus 1 k's power. Product of those two, now this one is just positive one. So you may erase everything. Okay, now you can get finally this beautiful, more simplified. Okay. Okay. Then this one is the largest number because this is increasing order. This is the largest number. Okay, so that is you can convert this one into uh, the numerator. The numerator is now this one. Okay. Okay, so the numerators can be replaced by this one, and the denominator is this one. And then this is exactly equal to m plus k minus n k. Okay. The, the calculation. So using this kind of explanation, you can get final answer is minus x 1 over minus x n is equal to this one. But there is a second proof. You may use differentiation. So this, by Taylor series differentiation. The first of all, this one. So now everybody know this one. And then what is the power series expansion? This one. Okay. There are two ways. So for, using the generalized binomial theorem, you may use minus 2. Okay. And then what is this? This one is sigma minus 2 k, k is 0 to 1, and minus x to the k. Okay. So this is the generalized binomial theorem. Then you can get this result. But there is another method because now 1 minus x minus 1, take derivative. Take derivative. Then what do you have? This minus 1 comes out, and 1 minus x is minus 2. And the inside of this one, there is minus 1. The derivative of the 1 minus x is minus 1. So this one is cancelled out. You can get this one. So this is the derivative of this one. Okay. And then take the right-hand side also. The right-hand side one is, the derivative one is now 0. Derivative of x is now 1. Derivative of x squared now is 2x. Derivative of x cubed is now 3x squared. Likewise, by taking derivative of each terms, you can get the result. So this is the second method. This one, in this case, we use the differentiation. So this is the second method. Okay. In this case, we use generalized binomial formula. In this case, we use differentiation. Okay. And then in this case, also we need mathematical induction. Mathematical induction. So I mean, if we accept this one, then uh, what is it? Minus x and plus 1 like this. But for this incoming Monday quiz problem, uh, say this one. So in this case, math induction is a little bit difficult. So it's okay. Just uh, express this kind of, okay. Just think about this relation, and that is okay for me. Okay. So uh, I want you to understand how differentiation can be used to get the power series. This one can be, we say, the power series expansion And there are two methods. Okay, the one is the using the Taylor series expansion, but also binomial expansion. But both of them have exactly the same result. So this is the one of the beautiful uh, interchange between Taylor series and binomial theorem. Okay, so this is the Monday quiz problem. So let's go to the another Monday quiz problem. A generating function comes out to solve Fibonacci problem. In fact, in the history of mathematics, the Fibonacci problem is a very famous the problem. So in our midterm examination, we approach Fibonacci number problem using what? Lindenmayer system. Lindenmayer system. Okay. So this is other rabbit and baby rabbit, something like that. So using a kind of alphabet symbols, symbolic manipulation, we can approach Fibonacci numbers, Fibonacci problem using a Lindenmayer system. So that is a very important one because using computer coding and computer algorithm, we can generate a possible solution using this kind of Fibonacci problem. But for the final examination, we use a generating function. But this is usually this one is a final examination problem for mathematics major student. But instead, since you are a student for you majoring IT and computer science, so it's a little bit difficult. So I changed my mind. Instead of this one, I just uh, uh, want you to know how to use a generating function to prove our old friend. This is a very our old friend. Okay, so generating function can be used widely but in the history of mathematics, a generating function is the first they used for to solve Fibonacci problem. But instead, we will study how to use generating function to prove this one. Okay, so to prove this one, there are three parts. Three parts. Okay, so the first part and second part will be our quiz. But the third part will be our final examination. Final examination problem, okay? Oh, final examination also this was the review problem, review test. So the review test, and there comes four problems. The first problem is what? So as I announced in WhatsApp, the the grace test problem. First one is find out greatest common divisor A and B. Okay, write down computer code and explain mathematical explanation how to find out a greatest common divisor of the given integer A and B. Okay, second problem is Fibonacci Fibonacci using linear system. So just use uh, letter A and B and Lindenmeyer's symbolic manipulation give a Python code for the Lindenmeyer system as you already uh, take that kind of thing in the midterm examination. So from the midterm examination, I choose two problems, this one and the Fibonacci problem using Lindenmeyer symbolic manipulation. And then I choose two from the second part uh, semester. The third one is now that is prove this one. Okay, binomial theorem and choose K. Same as like that. Binomial theorem, classical one. But instead, you can prove this one instead. Problem four is now the how to prove this one uses uh, the third part of the homework five. Okay, so the first part and second part will be quiz problem. The third part will be our grade test problem. Okay, and this one will appear in your final examination also. So to prepare our quiz problem, let's see. The first part is to find out the generating function for zero scale. So this is zero scale is zero, so it doesn't matter. The generating function of this one is this. So this is the first part. And then how to prove this one? See, let's read this one. Okay. So just the above side, we study this one. Okay. This is just we just from the above, then we prove this. So they use usually the K span. Okay. In this case, they use I or J. Okay, and K x K minus. Okay. So from this one, we prove. So this is almost equal to the previous one. Okay, like this one. Now then, it, uh, in this case, so this one is 2, but the exponent is 1. So I mean, this is k x k minus. So this is even though the quotient is 3, the exponent is 2. Then how to make kx to the k? That is, just multiply x to both sides, left hand side and right hand side. Then multiply by x both sides, then you can see what do you have. And then uh, instead of this one, then this one is by multiplying x1. Then this one is now okay, k times x to k, okay, k times x. But this one is k times x, k minus 1. So to reduce this one. So x times, now, to, now we need, now in this case, now we had 1 plus 1 x plus 2x cubed plus 3x cubed and 4x 4. Okay. Now, but so this is the generating function for 1, 2, 3, 4, 5. But we need to find out the generating function, the 1 square, 2 square, and 3 square, something like that. Then how to find out this one? But what's the derivative of this one? Derivative of this one is, now this is, there is 2. So derivative of this one is 2 squared x. Okay. The derivative of this one is 3 squared x squared. The derivative of this one is 4 squared x cubed. Okay, so now we get a kind of hint that just take the derivative of this one and then x times the derivative this one. Find out the derivative of this one first. And then what do you have? That is, and then that is like this. So 1 minus x squared times x. This one is x plus 2x squared plus 3x cubed, something like that. Then take the derivative of this one. This one can have what they have 1 plus 2 squared x plus 3 squared x squared plus 4 squared x cubed. Okay, but this is a 3, but this is 4, but this is 3. So that's the reason why. How about multiplying x time? Then this x is now comes x squared. Now this x squared x cubed. Oh, sorry. Right? And then the x to 4. So x times the derivative of this one is the answer, and this one is the generating function for the squares. So that is, what is derivative? Derivative of this one is this one, and x time is to have this. So let's find out the derivative of this one. Find out the derivative of this one. Then I'll find out the derivative of this. There may be two ways. This one can be, think about the product of function, 1 minus x minus 2k. So now this is the f times the derivative of this one is f derivative of this one plus g plus f g plus. So you may use this one. So derivative of this one is 1, and so that is f prime of z, and then 1 minus x minus 2 plus. Now f is, now this is x. Now x times the derivative of this one. What was the derivative of this one? 1 minus x minus 2. Derivative of this one is, now minus 2 is comes out. 1 minus x. Now this subtract 1 is minus 3. And the inside of this one, you get the derivative of 1 minus x minus 1. So then 2 times what? 1 minus x minus 3. Okay, minus 3. Okay, then let's solve this. So that is 1 minus x, this one, plus this one is 2x, 1 minus x cubed. Okay, then how about to make this one, the product, if the denominator is 1 minus x cubed, the numerator is 1 minus x, can be 1 minus, okay? Then sum of those two is, now there is minus x there, and this 2x, so that is 1 plus x. Okay, so finally you get 1 plus x. The denominator is 1 minus x cubed. So that's it. So this is the derivative of this one. And there comes x, and this will be our answer. So you may see this one. Well, you may read uh, this one. Okay, and or you can watch this YouTube. And then finally, what is the generating function? Is it 0, 1 square, 1 square plus 2 square, 1 square plus 2 square plus 3 square? So this is important because now we want to find out the generating function for the sum of squares. Now the really important one is part three. This one will be our quiz problem, the grade test problem. So I will explain this one uh, later, and then I will provide you another video for this one. But for this quiz problem, then let me explain this one in this video. So the answer is now this is the generating function for what? One squared, two squared, three squared. Sorry. Okay. Just multiply this one, then you get the generating function of this one. Okay. The why? This is very beautiful mathematical explanation. Okay. Then let's use this YouTube to explain this explanation because so from this YouTube, just watch this one from 11 minutes 20 seconds. 11 minutes 20 seconds. So let's click this one rather than this one. Click this one. Let's see. 11:20. Go to 11 minutes. 11 minutes. Why this one is? I want to enlarge this one. So this is a small one. I want. Yes. Okay. This one, this one is very important idea. So this is important. Okay. So when you have this kind of thing, by multiplying this one, what happens? A0 is 1 squared and squared x squared, 3 squared x cubed, something like that. And those, so you can get the summation for the okay, so this is a beautiful explanation. Okay, there may be another way to find out the uh, another explanation. Okay, so this is exactly the same. So you can get this one using the differentiation binomial method, but there is another method. Okay, so this one is not necessary. So let's skip this one. Okay, so now she introduced very uh, important fact. Okay, but without proof, but it's okay. So let's skip. Let's stop here. Okay. Watch this one and from this one. So once again, the let's remind you. Okay, let me give an example. Very speed. So, so let's see. One times of this one is one squared x plus two squared x squared plus three squared x cubed. Okay. Then so etc. Then what is x times of this one? X times of this one is now one squared x squared. Okay. One squared x squared plus this one is x times this one is two squared x cubed. Okay. Now how about x next time? X squared times this one is one squared x cubed. One squared x cubed plus something like that. Okay. And then so taking all the sum, then you get one square x. Okay. Let's see. And from this one, what is one square plus here, one square plus two square x square. Okay. And what you get from this third column, you get one square plus two square plus three square like this, okay? So in this way, in this case, we can get a kind of hint, we can get a kind of ideas by multiplying this one. Now we have this kind of power series, and in general form is the coefficient for the x to the n is the sum of the squares from 1 to n. So that's exactly what we want, okay? So the generating function for this kind of sequences that just multiply 1 over 1 minus x, and you can get the result. So let me finally explain this one. So in our previous one, we can get this one is 1 plus 2x plus 3x squared, something like that. We can get using Taylor series, and also, okay, let's go to this one. So one of the most important aspect of mathematics is there are many ways to prove the fact. Okay, that is so. One of the reasons why the mathematics is beautiful is there may be many ways, many beautiful way to prove the same thing. And that's very important in mathematics. Okay, so in this case, they use Taylor series and the differentiation, but also you can get what binomial method. Then let's find out another method. Okay, so that is how to find out 1 over x squared. And let me see, this is 1 minus x times 1 over 1 minus x. Now, what's the effect of multiplying this one to this function? This function is 1 plus x squared plus x squared, okay? And then, as you see, I multiply this one. So a0 plus a1x plus a2x squared plus a3 okay? By multiplying this one, then you get a0 plus a0 plus a1x plus, sorry, what happened? Hmm. So this one is a0 plus a, something like that. Then from this region, as she explained in the video, oh, you get exactly the same result, okay? Because this one is a0, this one is a1, this is a2. So you 1 plus 2x plus 3. So this is 1 or plus 1 plus 1, 3x subject. So this is another beautiful method to find out those exactly the same result. Okay, please watch out this video. I think it's better to watch this video next Monday before taking quiz. Thank you very much for your attention.